At a glance, we can see that the surface finish of this part is incredible. But we need a way to quantify that. We need to know exactly how nice the surface finish is to meet maybe a dimensional requirement. That's where a profilometer comes in. So typically, a profilometer is going to have a stylus, which we'll use this ball and mill to represent, and that stylus is dragged across a finished surface of a part. As we drag the stylus across this part, we can see that it goes over the peaks and it falls into the valleys, measuring those heights as it goes, and that's going to create a line graph of the roughness profile of the part. Now, the problem with a traditional stylus is not only is it not able to fall all the way into the smallest grooves, but it actually is leaving a mark on this part as I'm dragging it across. Now that's where Keon's came in with an optical profilometer. An optical profilometer uses lasers to measure surface profile. Those lasers are going to find their way into every groove of the part, and they're not going to scratch the part. Now the output of that scan, so looking at this graph might kind of seem a little bit meaningless, right? There's a lot of data points across this whole entire spread of the part. We need to boil that down into a digestible, measurable number. Now, that is where the RA and RZ values come in. Let's check out Mastercam to show what makes those values. So here in Mastercam, I have a surface roughness profile, just the full graph. To boil this down into an RA value, we basically take the average of all the points across the graph and find the average deviation of those points from the mean line, or 0. In this case, the RA value of this scan is going to be 0.2 microinches. Measuring surface finishes with RA is more common in North America. Now, what RA does is it kind of neutralizes the peaks and valleys, like the worst of the worst, and kind of boils it down into one simple, smooth number. RZ, on the other hand, is used more internationally, and RZ takes into account all those peaks and valleys in 5 separate chunks, takes the average of those values, and in this case, the RZ of this graph is 0.6 microinch. So looking at our results of the scan, we can see that this part achieved a 0.3 microinch RA value. So somebody in the industry knows that a 0.3 microinch RA value is an outstanding result. That's a really, really great surface finish. But what does that mean to the casual observer? So if we scale this up so the curvature of this part is equal to the curvature of the Earth, the RA, the average roughness, is 5.9 inches tall. That is outstanding. This project was a huge learning experience for me. It was great learning about how surface finishes are measured using the optical profilometer from Keon's. With that tool and this part, we proved that Mastercam is capable of sub-micron surface finishes.